I'm going to do a couple of problems here from Math 126. It's the open enrollment class, so it's using the Lumen material from section 3.5, number 16 to 17. So number 16, we're going to find all the zeros, real and non-real, of the function. So let's start off with looking at our constant and our leading coefficient and our factors of p, which are the constant, the 135, going to be plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15, and let me see, I was working on a list here. Oh, plus or minus 9, forgot about that. Plus or minus, I think it's a 9 times 15 gets us there. And then 27 plus or minus 27 because it's 5 times 27. And plus or minus 45. And then plus or minus 135. Our q's are going to be the factors of 4. So we got plus or minus 1, plus or minus 2, plus or minus 4. So our p over q is a pretty big list because we have 1, 2, 3, 4, 5, 6, 7, 8. 8, and then over the 3, that's going to be 24 things. I mean, we're looking at our p over q's. I don't want to do the whole list, but plus or minus 1, plus or minus 3, plus or minus 5, plus or mince 9. We can start getting really big, and it's rarely something that's going to be that big. Now, the list goes on, but also would include things like we have 1/2, 3/2, 5/2, and then it'd also be things like 1/4, 3/4, 5/4, and so on. Okay, so it's a pretty big list. Like I said, 24 things. And if you count the plus and minus, makes it 48, by the way. So let's go ahead and start with something smaller. And also, if we look at sign changes, it's 1 sign change, 2 sign changes, 3 sign changes. So we look at our plus minus constant, or no, complex, excuse me. Looks like we'll probably have 3 or 1 positives. If we look at our f of negative x, we're going to have 4x to the 4th plus, no, it's still minus 67 x squared. Then it's minus 138x and minus 135. So that's 1 sign change. And 1 there. So we'd be at 0 complex, we'd be at 2 complex. So I would look for 1 positive, 1 negative, and then probably from there use a quadratic formula to see what's left. And they could be positive or they could be complex. So let me just randomly start somewhere. I don't like to start too big, probably bigger than 1. I'm going to start at 3. 4, negative 4, and then 0. Then negative 67. Then 138, and then negative 135. So that's 4, 12, 12, 36. So we have negative 67 plus 36. And we get negative 31. And that's going to give us a 93 negative. And we get 45, and check that out, because 45 we found earlier. It worked out to be, that's positive 135, so we get 0. So 3 is one of our zeros. Now, I'm not going to go on the negative side. But I'm not going to go any more positive. I'm going to go to the negative side. Now, I notice here the 45 We could try 3 again, do it like a -3. We could try 5. I'm going to go 5 because 5 is bigger. That'll tell me not to try anything else. Or -5. 5 is smaller, I should say. Not try anything smaller. So 0. And then we have -20. So we get -8. We get ourselves a 40. Next going to be a 9, -45, and a 0. Hey, look at that. We found another 0, -5. Now what's left is 4x squared minus 8x plus 9. If we set that equal to 0, we can use a quadratic formula. So it would be x equals negative of -8 plus or minus the square root of -8 squared minus 4 times 4 times 9, all divided by 2 times 4. So it's 64 plus or minus the square root of 64 minus 4 times 4 times 9. That's 16 times 9. Isn't that 144? It is 144. Divided by 8. And so we have 64 plus or minus the square root of 64 minus 144, I believe that's 80. I am -80. So what can we reduce out of this is the question. We have a 64 plus or minus, that's 8 times 10, that's 16. Isn't it 16? No, 16 times 5. That would work, 16 times 5. So if we treat this as the square root of 16 times -5 over 8, we end up with 64 plus or minus 4 times the square root of -5, or I might as well call that I root 5 over 8, and we can reduce the 4 out. So 64, where did I get 64? See, this is where it's nice to do this in class because someone would call me. I'm like, where'd you get that 64? I don't know where I got the 64. So that should still be an 8. I was thinking of the square underneath the radical. And so let's see. We're going to divide a 4 out. I guess got 2 choices of what we want to do. 8 divided by 8 is 1 plus or minus the I root 5 over 2. Or you could do 2 plus or minus I root 5 all over 2. So that gives you your other 2 zeros. So they are obviously complex. So I would say 2 plus I root 5 over 2 and 2 minus I root 5 over 2. Okay, I'm going to stop this video here because it's taken a little longer than I expected. So then we'll go on to, I'll make another video for 17 because I know that students don't like videos if they're more than 3 minutes, and we're already at 8 minutes. So, okay, pausing here. See me at the next video for the 17.